back, everyone. Part 2 of Chapter 5, Logarithms. So this part, basically, we will make use of the index number, and we will find the index number or the indexes, the base number of indices. Now suppose we have a number. In previous part 1, you get a number, and it is a power x. So this is a base number. This is an index number. Maybe label it. Okay, another number color. Maybe use violet. This is the indices, index number, and this is the base number. Base number. Now, in part 2 is you emphasize on how to look for this number. How do you get to find what is this number? From here, simply you bring down the base number, bring it down, you apply log. You have a log. A is a subscript number to the power n is basically equals to x. Log base a to the power n. Oh no, sorry. Log base a to n equals to x. This concept found by John Napier, a Scottish mathematician. So I would suppose that by now you should be able to tell what's the number. If I were to have b power 0, b power 0 is basically equals to 1, I emphasized earlier. I'm going to do it again. And b power 1 is basically b. Now it's true, if you were to apply log, you bring it down, the b you bring it down, therefore I have log b1 is 0. And log b is basically 1. Now, if you put into graph, help you to remember easily. Suppose you have a graph. This is a positive x direction. This is my positive y direction, which is log 10 to x. When this is 1, you get a graph that looks cut by here and approach it. Here's 0. This is a graph for log x. There's no way that you get log 10 0. It's infinity. You never get log 10 0. Basically is infinity, undefined. There's no way to be 0. That's I think I emphasized earlier. I'll give you an example to make do with log. You should be able to use the table. Henry Briggs developed a table. If it doesn't have the table, you may make use of the scientific calculator. Basically, log 10 is a common logarithm. Log base 10x is a very common logarithm, common log. You may use a calculator or perhaps the table. Now let's give an example of how to use calculator to perform a calculation or some method in simplifying the equation. Says you have log 381 equals to x. You say, hey, the base is 3, not 10. So how can you do it? It's simple. It doesn't need to worry. This is by simplifying it by using the methods shown here. Revert it, 3, bring it over, 3, bring it up. Therefore, 81 is equals to 3 power x. In order to get 81, common factor is 3. So you would know that is 3 power 4 is equal to 3 power 4. You are simplifying the base number, and x is 4. Sorry, this x is 4. Therefore, your x equals to 4. Simple. This is x, sorry. It's very simple. There are times that you will not be able to tell what is what. All you need to do is bring it up for these instances. How about there are times when you need to use a table. Say for example, now I will not be able to use all example to show. Make use of a few, and then maybe 0.049. You should be able to practice as time goes. You need to find what's the value here. If you have a table, you log 10, 0.049. You should get the answer. Or you put it in a calculator. Yes, calculator, scientific calculator. The answer is supposed to be negative 1.3010. Is this part of law of algorithm. He will be able to tell you how to do it. 0.0 is a negative number. But for now, you just use the table or calculator to perform this kind of calculation. Make use of the shift key. Now next, I'm going to use another example. I think I've done with example. Let me highlight some of the law involved. First law, I think I'll go to the next page. Law of logarithm. First law, I will have log of any base, maybe base 10, or any base. I will use log base b. Mn, a number times with another number, m times n. If log b m times n, that's basically log b m plus log bn. When it's time, you plus. I'll give you an example. Says what happened in the case of a simple one at the moment. I have log b, maybe 6. 6 is basically log b2 plus log b3. Now, this is just a concept, mere concept. We're not going to get any solution. 6 is 3 times 2, so plus. Okay, simple example at the moment. 1, 2. I'll try to give you an example. More exercise. A practical one that we will use during exam later. But for now, just bear with it. So if we were to divide a fraction, m divided a number, divided by another number, they will log b m minus log bn. You may want to look into my first part of chapter 5, the indexes. A very similar form, but when a number, this is different, yeah? This is different. Please do not confuse. It's not the same as with log bm over log bn. It's different. It's not the same. It's wrong. Do not equate it to this. When it's a number by a number, log a number by a number is log number minus log number is minus instead. Please take note of this. Third one. Now log b m raised to the power n power. So when there's a power of a number, therefore it will be bring it to the front, a constant m. This could be a round number and it could be a fraction number, the n. The fourth one, you may want to copy down this a piece of paper, or you may download my video. You may rewind it, pause it. You may pause it while doing exercise. I'll try to go through it slowly so that you have time to pause it. Fourth one, the change of base. Change of base says I have log bn, and I want to change this base to log a. So what you do is you equate it to a fraction. Now this is a fraction. So log, I change new base with a new color. So log a, maybe I'll use log a. Remain the one is on top, is n on top. B subscript below, so put it below log. Whereas the base is a new base, log a. And this is your b, base number. Change of base. Now if you want to change a base with the same number n, it will be, says if I were to have log bn, I want my base number to be n, so therefore it will be log n over log nb. So log n will be 1 over log nb. Now this is what we have just now, the 1. N power 1 is n. So you bring down the n, log n is 1. That we learned earlier. Let me highlight you a few examples that make use of the law that I've shown you. Say for example, of time constraint, I'll make it short. You may of course just go through the question from any exercise book. To start out with, example, maybe you go to next page. Example, for practice purpose, 1. 4 power 9 equals to 9. Solve this, solve for x. You can't simplify it, so what you do, you apply log to both sides. Maybe my log number, log 10 4x to both sides, log 10 both sides. Here would be x power x, power up, the previous page. When there's a power, all you need to do is to bring this power to the front, here. Okay? This one. So what you need to do is you bring x to the front. X log 10 4 is log 10 9. So therefore x is, you put in the calculator. Now this is dy. You don't confuse over, you treat log as the whole number. 4. Put the calculator, use a shift function, turns out to be 1.585. Right? A more complicated one, example, question 2. says I have log 3 2x plus log 3, common base is 3, this is x minus to the half equals to 1. Now this is a question, if you're in now form 4, you'll find it very hard. But let me tell you a trick. To make it simple, simplify it. Based on the law you have learned, we have a plus sign, log 3, a plus sign that would be a multiply. Let me go to the previous page. If you have a plus sign, all you need to do is, of the same base number, a plus sign, all you need to do, a number times with another number, a number times with a number. Okay? Let me go back to the next page. Plus sign, log and a log. All you need to do is times the number. It's simple, isn't it? So therefore it will be log 3. Oopsie. Accidentally. That will be log 3. 2x. Maybe you need to learn how to use a square bracket. It's about time because in our form 4. 2x times x minus half. Round bracket, square bracket equals to 1. It becomes so simple. This is 3, this is 1. Now you bring the 3 up, bring up the 3. Here, this 3, you raise it up. Therefore, here that would be, and then you times in this number with this number, this number with this number. That would be 2x squared minus x is equals to 3. 3 power 1, that would be 3. Then it's simple now because it's now quadratic equation that you learned in chapter 2. Minus 3 equals 0. You should refer to my OCW series, how to get this factor, or you may put into calculator. And it turns out to be, equals 0. In order to get 0 is a number times another number, you get 0. 2x squared, so you expect this 2x, here will be x. 3 is either 1 times 3 or 3 times 1, but the sum of them is negative number, so you would expect here would be minus 3, maybe plus 1, so it's negative 3x, 2x is negative 1x. This is how you get negative 1. Yeah, let me have a look at it. So therefore, my 2x minus 3 is 0, or x plus 1 equals 0. So now x equals to 3 over 2, which is my answer, because my x must be more than 0 in my previous page. For this case, this number has to be more than 0. Here, let me show you the graph. A log 10 and log 10 of 0 is undefined. This graph, your log of x, this x has to be more than 0. You may want to download my video, pause it, rewind it when time comes. Last part. There are more to go, but of course I simplified it into half an hour. I'll try my best. First law, first line would be to simplify equation. Look for anything they have in common, and then easily if you to solve it. The next example would be the substitution method in solving equation relates log with indices. We have gone through equating the indices just now. We have also apply of log. Last example would be substitution. Need to let equation doesn't have any equation at hand. I will show you how to solve by equation. There are times that you need to substitute. Let m is what, and then yeah, maybe a simple one. Given log 5p is equals to m, log 5q is equals to n. Then express log root 5 25 q over p in terms of mn. So if you look at it, it's so complicated. Bear in mind, the rule to solve this is always the same. Simplify them based on by using the law. Simplify log dy, that will be subtract. Yes. So therefore, that will be equals to log root 5 25q subtract log root 5 p dy. Number divide number is minus. Then what you are given is 5, but here you are given is log 5, log root 5. All you do is change of base, change to 5, and therefore it will be log 5. You just copy what you have over log 5. Here is root 5 minus log 5p over log 5 root 5. Here you have log 25q is a number times a number, so this is plus. Then will be log 5 25 plus log 5q over. Now here is root 5. Root 5 would therefore be half. Front log 5 5. I hope you know why it's half, because when the square root is half, so you bring it to the front, it's become half. Subtract log 5 5 over half root 5 5. You find that the denominator is the same. Log 5 5 is 1, so you expect the denominator is half. So therefore here log 5 5 is 525, so you will expect 5 5 squared plus log 5q minus log 5 5. I just copy what I have earlier, simplify the denominator is half here, because log 5 5 is 1. So therefore log 5 5 is 1, so here is also equal to 2 times 1. 2 times 1. 5q is n plus n minus log 5p, log 5p. This is supposed to be p, log 5 5, log 5p. So therefore log 5p is m over a half. So you bring it up, therefore that would be 2 times 2 times 2 plus n minus m is the answer. Simplify. So this example, I'm going to show you, no matter how complicated is your question about logarithm, first rule and the only rule to solve it is to simplify. Line by line, simplify it. It doesn't need to jump steps. Simplify them accordingly. Step by step, eventually you get to the answer. Now I hope you like my video. This is all about chapter 5. I hope you will press the thumbs up button down there. It means that you like my video. I don't mind if you want to share it over your Facebook or any other social media. It helps a friend too. And that's the main intention of my OCW series, is to help people from around the country. Free tuition is possible. And I hope it helps you in your exam. That's all from me in this chapter. Stay tuned to my following video. Thank you.